Hi, good evening. Welcome to another session of this class, Statistics for Analytics. This week we will be looking at chapter number 2. Chapter number 2 will be looking at graphs, charts, and tables for describing your data. So topic 2 will be how do you describe your data. We have numerical descriptive, which we will cover next week. This week we will be looking at a graphical description of your data. We have 7 learning outcomes for today's class. Outcome number 1 is we will learn how to construct frequency distribution, both manually and with your computer. Outcome number 2, we will be looking at how to construct and interpret a frequency histogram. Outcome number 3, we will look at how to develop and interpret joint frequency distribution. Joint frequency distribution means you have two different variables or characteristics you want to link them together. Outcome number 4 will be how you will learn how to construct and interpret various types of bar charts. Outcome number 5 will be you will learn how to build a stem and leaf diagram. Outcome number 6 will be you will learn how to create a line chart and interpret the trend in the data. And finally, we will look at how to construct a scatter diagram and interpret it. So those are the 7 learning outcomes for today's class. Okay, why do we need to know how to describe the data? There are several reasons. Currently, we are living in an age where you see a lot of graphical presentation like this, right? Okay. And the quality of presentation of graphs and charts have increased. So although written words are still very important, people understand graphics much more easier. People visualize or they can construct the images much more clearly by looking at charts. So that's why understanding of the different kinds of charts available is important so that you know when to use which kind of charts. The old adage is a picture is worth 1,000 words. But currently, if you see many software is developed by using pictures, where you can present whatever information that you want to describe in terms of infographics. Okay, so we still have lots of visual images that are being shown through the internet. We have television, we have handphones and computers. And these graphics are becoming sharper and sharper and sharper. Previously, we have not very clear pictures. Now we have like 2K, and then we have 4K, we have 8K, we have different types of visualization that is happening. So understanding this is important so that as an employee in a company, you will be able to use them to describe whatever situation you have to anybody. Okay. So when you start working in a company, you will be at 2 ends of the spectrum. The first spectrum is the end where you do it. Okay, you do it for reporting. The other end of the spectrum is you want to use it. Okay, do it and use it. 2 different things. Use it is when you are a manager and you're given some pictures or graphics. You want to interpret them. So the first part is, let's say you are doing some presentation and you have to present your presentation in terms of report or using some visual graphics. This is where you are actually using some knowledge of these tools to present your data. This is the other end of the spectrum. So the second end of the spectrum is when you become a manager, you also receive lots of report from consultants and also employees or from other departments. Now you must be able to visualize and make sense of the graphics that is presented to you. That is why we will work on both ends, depending on what level of managerial position you hold. somehow you will be able to do that. Huh? And now in many business reports, newspaper reports, and also magazines, for example, we have Forbes, we have Fortune, we have Bloomberg. They use a lot of graphics to present. So we have a term called infographics. Instead of presenting them in terms of numbers, you can present them in terms of pictures or some charts. Okay, if you see the magazine called the Wall Street Journal, they have lots of tables and display of data in different formats. So as a user of this information, you should be able to decipher the different kinds of visuals that is presented in these reports. And throughout your career, when you start working or you're already working, you will be both a producer and a consumer. So in many companies now, they collect a large amount of data. So if you go to a supermarket, every time you check out, they will know what kind of product you bought, at what time, what day of the month. They have all this information. And also these informations are by different product categories. Okay, so you already have this information. So how do you visualize this information? So you need a solid understanding of the tools and techniques available so that as a person who consumes data, you will be able to present them in forms that are more easily visualized. Okay, so that is why we need to understand how to present the data. The first type of graphical or tabular distribution that you can do is called the histogram. This histogram is actually a frequency distribution. First, let's say you have age of the student. These are the age of the student, which is not sorted. What we will do is we will sort them into these groups. So let's say those who are 18 years old, there are 4 of them. 19 years old, there are 4 of them. After we have developed this frequency distribution, we can show them in a form of a chart or a table. Okay, so let's say we have here different product categories purchased by Walmart customers. The product categories are numbered. Okay, and then we want to know for each product category how many times they were purchased. Okay, how many times they were purchased. So these numbers are actually representing the product categories sold in Walmart. Okay, and how many times they appear? Let's say we take a number 10. You have number 1. We have 2, 3, right? We have to count how many times. So if you have raw data like this, it is very difficult for you to visualize which product category is bought a lot or is selling well. Okay, so that is why what we will do is first we will sort the product category, which is from number 1 to 11 categories. We have 11 categories of product. Based on these 11 categories of product, we will now count the number. How many times product category number 1 was bought? Here you have 1, 2, 3, 4, and so on, right? We will count them. And now we are summarizing them into a table. Once you summarize them into a table, now we can see much more clearly which is the product that is bought a lot. So we have product category number 4, which is bought 92 times. We have product category number 5, which is bought 86 times. And we have product category number 6, which is bought 68 times. These are the 3 main product categories that is selling very well. So once you have this kind of information presented, then the company can make some decision based on this distribution that these are the 3 product categories that we need to stock up. Okay, we have a number 11, product category number 11 here, right? This is bought to a very little extent. So maybe you want to reduce the stock of these product categories. Okay. Okay, so that is some of the decision that can be made by a company based on this frequency distribution. So to do frequency distribution, your data must take on countable numbers. Your countable numbers, that means you can count how many categories you have. It cannot be too big a number, which is uncountable. Then we can do frequency distribution. For example, we have student ages. We can divide them into different age group. Walmart customer product categories. We have different product categories, number 1 to number 11. We can also count number of late deliveries per month, 1, 2, 3, 4. Number of touchdowns scored per game, and many other variables which are countable. How many number of female customers we have in a month, how many number of male customers we have in a month. That kind of categories we can do to get a better picture of our client base. So to develop a frequency distribution for discrete data, first we need to list the possible values. These are the possible values. So here we have a number 0, number of late deliveries per month. 0 is the lowest and 5 is the highest. Okay, so sometimes we have 2 late deliveries in some of the days, right? We have 2 late deliveries. Some days we get 3 late deliveries. Some days we don't have any late deliveries. So this is the number of deliveries, let's say, in a month. So now what we want to do is we need to group them into the categories. So we have 0, we have 1, 2, 3, 4, 5. So based on the number we already hear, we can count how many times A happens. So we have 0, we have 1, 2, 3, and 4. So what we do is, you might have learned in your undergraduate classes, we will use numbers like this. 1, 2, 3, 4, we count. And then when you have a number 5, we will put a slash here, like here. So number 2 appears 11 times. Okay, 2 deliveries, 2 late deliveries happen 11 times in a month. So when we count the number 2, 1, 2, 3, 4, and then we cross. We already have 5 here. 1, 2, 3, 4. We cross. We have 5 here. 5 plus 5 is already 10, and one more time. So 11 times. So from the unordered category, we will group them into these ordered categories. So those are some of the things you can do before you develop your frequency distribution. Okay. After you have developed your frequency distribution, we can also calculate another distribution called the relative frequency. The relative frequency is the frequency in that particular category divided by a total number. Okay, divided by a total number. So here Fi is frequency of the ith value of the discrete variable, n equals to summation of 1 to k. Okay, and this is the frequency total number. And then we have the k is the different values for the discrete variable. Okay, here we have 1, 2, 3, 4, 5, 6 categories, which is actually the k, and then the n is here. We can total up. Sorry. When we total up the frequency, 4 plus 5 plus 11, 20, 20 plus 10 is 30. So 30 is the n. Okay. So when we take this each group 4 divided by 30, you get your relative frequency. Okay. That is what we will do like here. So we already have our number of late deliveries. We have the frequency. So the frequency for category of 0 late deliveries is 4. 4 divided by 30, you get 0.133. 5 divided by 30, you get 0.167. 11 divided by 30, you will get 0.367. 7 divided by, so you get all this. The total will be 1. Okay, the total will be 1. Okay, so that is how you get your relative frequency. Okay, the total frequency here will be, the total will be 1, because if you total up 30 divided by 30, you will get 1. Okay, that's how you calculate a relative frequency distribution. So now we have the number of days. Let's say an advertiser, he asked 200 customers how many days per week they read the daily newspaper. Some people don't read at all. Some people read the newspaper every day. Okay, so we have the number of days read is 0 up to 7. And out of the 200 frequency that you get from the 200 customers, 44 of them do not read at all, and 30 of them read the newspaper every day. Okay, every day. So to calculate a relative frequency, let's say for this 2 days read, it is 18 divided by 200. So that's how we can calculate the relative frequency of each category. And finally, we have the total frequency will be 1, right? Because 200 divided by 200, you should get a 1. Okay. And let's say you want to know how many percent of the people in the sample reads 2 days in a week. Okay, read 2 days in a week is 9%. Those who read 0 days in a week is 22%, and those who did read every day, it is about 15%. So once you do this, you can convert them into percentages. Okay, so those are the things we can do with frequency distribution, which is relative. So if you want to do this in Excel, these are the command that you can do in Excel. We will use SPSS a lot, right? So we will use SPSS. So this data I can share with you. You can actually try it out. Open this sports shoes data, and then to run the number of Nike shoes. We want to know how many number of Nike shoes is bought. Okay, so what we do is we run analyze descriptive frequencies. We will pick the variable called Nike, and here the number of bought is 0 up to 8. Okay, 0 up to 8. So from the data we already get here, they will sort them into groups. So we have those who bought 0 times is 27. Those who bought 8 times is 2. Okay, so we can also calculate the relative frequency, which is this column, right? Okay, 27 divided by 100, you get 27%. This is also 20 divided by 100, you get 20%. So this command in SPSS called descriptive statistic frequencies will give you the frequency and also your relative frequency. This frequency and the relative frequency is the same because the total is 100. That's why it's same. Usually you don't get the same. Okay, so that's how you can get frequency and relative frequency in this software called SPSS. Okay, so far talk about how do we group data into frequency distribution when they are discrete, they're countable. Let's say we have data which is continuous. Continuous data are by default uncountable. Uncountable means you cannot count. The numbers are too big. Okay, the numbers are too big. For example, we have weight, we have length, we have time, right? These are all uncountable, right? Okay. So if you want to summarize them into groups, we can also do that, but there are several steps you need to do. So we need to build some classes. Okay, and some of the criteria for these classes is your classes do not overlap. Okay, for you have class 1, class 2, class 3, each class must not overlap. And all these classes must be inclusive or collectively exhaustive. That means each value you have in your data set, they must belong to one of the classes. And classes should be of equal width. Okay? If possible, sometimes you don't get equal width. Okay? And these classes are calculated between the difference between the highest value minus the lowest value in the class will be the class difference. Okay? And we try to avoid empty classes. Those are the criteria for building classes. There are many criteria that can be used to build classes. In different books, they will have different ways of doing things. You must also understand that. But for this book, we will use a format or formula that is given by these authors. I will share with you. So these are the 5 steps we will do when we have data which is continuous. We want to group them into certain number of classes or groups. Okay. Then we will follow these 5 steps. Step number 1 will be to determine the number of classes. That's a formula. And then step number 2 will be to establish the class width. How big is the class width? And then step number 3 will be to determine the class boundaries, the lower value and the upper value of each class. And then only we determine the class frequency for each class, number of data that is in that class. Okay, so those are the 5 steps involved. When we develop the classes for the intervals cannot be too small or too large. Okay, if it's too small, what will happen is you have too many classes. Okay, like here, 4 to 8, and then 8 to 12, 12 to 16, right? They are too small. So we have a lot of classes. If you put like here 30 in one group, there are too many in one group. Okay, that is also not a good thing. So that's why when we develop the number of classes, there is a formula that we can use to do that. Later, we can also revise the number of classes based on the distribution that we get. So how many classes that you want to develop for your data? This is the rule. It can be any number from 5 classes to 20. Okay, 5 groups to 20 groups. Okay. Okay. 5 groups to 20 groups, or 5 classes to 20 classes. The formula for the number of class is 2 to the power of k must be greater than n. K is the number of classes. Let's say you want 5 groups. 2 to the power of 5 is 2 times 2 times 2 times 2 times 2, right? Okay, that's how we calculate 2 to the power of 5. And this 2 to the power of 5 must be greater than your number of values you have in the sample. Let's say your sample is 30. The 2 to the power of k must be greater than 30. Okay. The minimum class width or the class width will be the largest value minus the smallest value divided by the number of class. Okay. Let's say you have 5 classes. You divide by 5. So that is how we determine this. Okay, let's say we have this data from 72 cities. Okay, 72 cities. These are the data that is already given to you. And these are times in second that it took to link the systems together from different systems that they have. To link them, this is the amount of time it is taken in terms of seconds. So we have a big number of values here. And if you see here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? So 12 in one column. We have 6 columns here. 12 times 6, you get 72 values. So first, we need to determine the number of classes, right? Okay, the number of classes, we will use the 2 to the power of k greater than n, right? N is 72. Okay, n is 72. Okay. 2 to the power of k, we can use, let's say we use 6. If 2 to the power of 6, you have 2 times 2 times 2 times 2 times 2 times 2. So 2 times 2 is 4. 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, 32 times 2 is 64. So 2 to the power of 6 is 64, but this is still smaller than 72. 72 is here, right? Okay, 72. So this cannot, because the 2 to the power of k must be greater than or equals to. This is the rule. So we can try 2 to the power of 7. 2 to the power of 7 is 128. So this number is greater than or equals to 72. So we decide on the number of 7 classes. Okay, 7 classes. That's the first thing. Okay, next, we want to decide on the class width. Okay, the class width. Okay, the class width is the biggest number you have in the data set minus the smallest number and then divided by 7. You get 208. You can also round it up to 210, but in this book, they say you round it up to a nicer class of 225. You can also use 210. Nothing wrong with that. So you can decide. So here they decided on a 225. So each group will contain the lowest value, the highest value minus the lowest value will have 225 second difference. That is what is meant by the class width. Class width. Okay. So here we have the boundaries. So the lower value is 0 and up to 225, but under 225. 225 up to 450 will be class number 2. 450 to 675 will be class number 3. And 675 to 900 will be class number 4. 900 to 1125 will be class number 5. And then class number 6 and class number 7. Those are the numbers. So once you have these classes decided, what we will do is we need to go back to the 72 values given here. We need to group them into the 7 classes. Okay, we need to group them into the 7 classes. Okay, so after we count them, we found that 0 to under 225, we have 9 values. 225 to 450, we have 6 values. And then each of this category, we already have the number. The total number will be 72. Okay, 72. They must be able to go into each. And what is meant by mutually exclusive means any value that you get in seconds, they cannot fall under here and also here. Because if you have 224, you will fall here. 225, you will fall here. Okay, that's how we decide. Okay, on the mutually exclusive. Okay, so this is an exercise you can try out on your own. Okay, we don't have to stop and do this. What we will do is you can try this out on your own at your pace, and then next week I will give you the answers for these 3 questions. First, we need to construct a frequency distribution. We will use the rule 2 to the power of k more than equals to n. And then the second one, we will develop a relative frequency distribution using the number of classes you construct in A. And then the third one, we will develop a frequency distribution and a cumulative relative frequency distribution from part A. So those are the 3 questions you need to do. The following week, I will give you the answers. Please try them out on your own, okay? Because later when you are doing your tests and exams, you still have to do them, okay? You like it or not. Okay, any questions on the discussion about frequency distribution and relative frequency distribution? No? Download what? Gangchen. Okay. You can decide on the number. Okay. Okay. What is meant by a nicer class is instead of 208.1429, nobody uses that kind of number. Okay. So what you can do is you can round it up to 210. It's easier. Okay. 210. What they are suggesting is you can use a nicer number of 225. So you can decide on any number so that a group will be like not like this. Okay, 208, 209, right? Okay, you can try 210. You can also try 225. Okay, you can decide. You still have the 7. You still have the 7. Okay, this data you have to, if you have the soft copy of the data, then you can sort them, right? Okay, Henry. Okay, because if you use software like SPSS, like this, right? Okay. If you have the number of years here, right? Okay. We can actually run descriptive, okay, here. You just run analyze descriptive, and you select your organization. They will give you the minimum and the maximum. I'm not ready file open data. Okay. Okay, it's not open. Okay, so you see the minimum and the maximum, right? Restriction means what? Jiacheng. Okay, we still have the same number of, we already have the 7 classes, right? Not all the numbers will be the same. Okay, so, and then we have a requirement, right? We have a requirement that says here, okay, empty classes should be avoided. So maybe you want to reduce the number. So here, if, let's say just now we have a 225, right? Okay. If you bump it 208, right? So if you say you want to take a bit of 250, some of the groups will be 0. Okay, that's why we don't use a too big a scale. Okay, width of the class. Okay. Okay. Next, we want to look at distribution, which is called cumulative frequency distribution. Cumulative frequency distribution. This cumulative frequency distribution is a summary that displays the number of observation with values less than or equal to the upper limit of each of its classes. So what we will do is we will take the first number in the group plus the second group in the second, and then we plus. So we will get a value called the cumulative relative frequency distribution. And then we can also calculate the percentages. So that is what we will do next. Okay, so we have here the classes 0 to 3. So the width of the class is 4, right? Okay, 0 to 3, 4 to 7, right? 4. This is the frequency. So we have 230 total frequency. So if you take 60 divided by 250, 230, you get the relative frequency. Okay, 60 divided by 230. We also have this cumulative frequency, right? Cumulative frequency is just the first frequency in the first class plus the second one. Okay, 60 plus 50, you get to 110. 110 plus 47, you get 157. 157 plus 40, you get 197. So we actually we are putting the total of the number of frequency in the first class with the second class for the second one. So that's what we call as a cumulative frequency. The cumulative relative frequency is the first cumulative, the relative frequency of the first class plus the second class. Okay, so 261 plus 217, you get 478. 478 plus 204, you get 683. Okay, rounding issues. Okay, so that is how we get cumulative frequency and cumulative relative frequency. Okay. Next, we want to look at histogram, frequency histogram. Histogram will have two axes, the horizontal axis and the vertical axis. The horizontal axis will have all the possible outcomes for the variable of interest. Okay. And the vertical axis will show the frequency of each possible outcome. So your x-axis is all the possible outcomes. Let's say you toss a dice. Your dice will have number 1, number 2, number 3, number 4, number 5, and number 6. That is the possible outcome. How many times each time? Let's say you tossed 30 times. How many times you get number 1? How many times you get number 2? How many times you get number 3 will be in your y-axis. Okay. And when we draw the bar, there should be no gap between the bars. Okay. That is what we call as the histogram. So here we have the 0 to 5 late deliveries. The frequency is 4, 5, 11, 7, 2, and 1, right? So the frequency will be here. These are the possible outcomes, right? 0 late deliveries, 1 late deliveries, 2 late deliveries, 3, 4, and 5. So for 0 late deliveries, we have only 4, right? This is the frequency. Here, this is the bar. And then the second one is 5. So the second bar. The third bar is 11, 7, 2, and 1. And there's no gap between the bars, right? Okay. That is what we call as the histogram. From the frequency, we actually plot them into this histogram. So just now we had the number of product categories. We have 11 of them. Product category 1 up to product category 11. And we have 450 purchases, right? 450 purchases. So the number of product categories, the possible outcome is 1, 2, 3 until 11. Okay, these are the possible outcome, which is here. And the number of frequency is given on the y-axis. So product category number 1 is 25. Product category number 2 is 29. Product category number 3 is 42, and so on. That is how the histogram is developed based on your frequency distribution. Frequency distribution. Okay, why do you develop frequency? The histogram is because of this reason. Once you develop the histogram, we can look at 3 things. Okay, number 1 is the center. So you can see here the center. This is the center, right? Okay. Number 2 is the spread. Okay, spread means how far they are from the center. This is your center. Are they spread towards the end, to the right, or they are spread to the left? That is called spread. And the third one we call the shape. Okay, is the shape more normally distributed? Are they distributed equally? Those kind of things we'll get from the histogram. Okay, so here we have 3 different histograms. Huh? Okay, here the spread is the same. Spread means the distribution is the same. Okay, the shape is also the same. But if you see the center is different, right? Here, the center is somewhere here, the center is somewhere here, and the center is somewhere here. So a histogram with the same spread and same shape can have different centers. Okay, midpoint we call it centers. Huh? Here we have all three distribution, which is histogram. They have the same center, right? They have the same center, but this distribution, and this distribution, they are very different. Okay, your distribution can be peaked, can be flat. Huh? Okay, that is what we call as the shape. Okay, the shape. Huh? Okay, so here the center is the same. You have different spread. Spread means how flat or how peaked they are, and also the shape, right? Is it mesochatic, platychatic? Later we will look at it. Huh? So these are some of the information that you will get once you develop a histogram. Huh? Once you develop a histogram. Huh? So this is an example of the NBA players' weight history. Yeah, from the players they have. They actually have the weights of each of the players, and based on the weight of each of these players, actual number of the weight in kilograms maybe. And then what we do is we divide them into two classes. 157 to 169, 169 to 181. Okay, this is below 169. This is 169 to below 181, so that they don't overlap, and you get a distribution like this. Right? You can see the shape. Center is somewhere here. Okay, and you see those people who are like 280 kilos and above, they are very little. Less than 160, 70 kilos also not so many. Okay, so we can get some indication from the histogram directly. Yeah? So if you want to do this histogram in Excel, you can also follow this instruction to do that. We can also do this in SPSS. We can also do this in SPSS. We will do frequency, click the frequency distribution, frequencies, and then descriptive. We can get the histogram directly from SPSS. So from the frequency distribution that we already get, we can also develop this OGIFs. OGIFs. OGIFs is actually the number of frequency you have divided by the total number. You get your relative frequency. If you do the cumulative relative frequency, the number will finally reach up to 1, right? Okay. The frequency is, cumulative frequency is 1. So for each category, you will have a number that you get. 0.002 is somewhere here. You plus 0.002 with 0.057, you get 0.0852, which is somewhere here. And then we can draw this OGIF. Okay. So we can have the histogram. We can also draw the OGIF on the histogram. Okay. So this is something we can do to see the increase. So this is the superimposing your OGIF on your histogram. Okay, on your histogram. So exercise number 2 is they give you these data points. Based on the data points, you have to construct a histogram with 5 classes, and they already give you the first class, 3.46 to 3.60. Okay, so the difference between 3.60 minus 3.46 will be the class limit, okay, or the interval, okay, or the interval. And then they have to develop a table for this, and then we can also calculate how many percent are at least 3.76% and above. Okay, we can do that. We need to also produce an OG for the data. So based on the discussion we had today, you can try this out when you have the time. Next week, I will give you the answers and how to do them. Okay, how to do them. Yeah. Any questions on histogram and OGIF? Okay, so far we have only looked at one characteristic at a time. Okay, one characteristic at a time. Huh? Now we want to look at two characteristics at the same time. Huh? They can be qualitative characteristics. They can be quantitative characteristics. When we look at two characteristics at the same time, we call them a joint frequency distribution. Okay, a joint frequency distribution. Huh? So in this week, we will only look at a joint frequency distribution. But after the break, we will be also looking at the same joint frequency distribution under a chapter called cross-tabulation. This is similar. Joint frequency distribution is similar to a cross-tabulation table. But in joint frequency distribution, we will not be calculating the proportion and doing the test. But in another topic called cross-tabulation, you will be calculating the proportion, and then also we will see whether there is a relationship between one characteristic and another characteristic. Huh? So here we have two characteristics. Number one is your payment method. Your payment method is charge and cash. Charge means you charge your credit card or your debit card. And then you have your payment by cash. And then you are parking in garage number 1 or garage number 2. So to do a joint frequency distribution, you must have at least two characteristics, payment method and parking garage. Then all the data that you have, you will group them into these 4 cells, we call it. Those who park in garage number 1, that they charge to the card, and those who park in garage number 2, who charge to the card, will appear in this cell. And those who park in garage number 1 and they pay cash, the number will appear here. And those who park in garage number 2 and they pay cash will appear in cell here. So this is how this joint distribution table is developed. So we have rows and columns. So now we can see clearly those who use charge card and they park in garage number 1 is 40. Those who pay cash and park in garage number 1 is only 10. Okay, so the total number 40 plus 20, 60, 60 plus 20 is 80. So we have 80 80 cars parking, and now we are dividing the 80 based on this joint distribution to see how many are using charge card. They are parking garage number 1. How many using charge card is parking in garage number 2. How many paying by cash parking in garage number 1, and how many paying by cash parking in garage 2. Here we can see clearly that more and more people are actually paying by charge card rather than cash. So this is what is called as a joint frequency distribution. So those are the numbers. So 80. We can also calculate the proportion. If you take the 40 divided by, we have many proportion we can calculate here. We can calculate the column total or the row total. If the row total means 40 divided by 60, you get a percentage here. 20 divided by 60, you get a percentage here. 40 divided by 50, we get another percentage called column percentage. Okay. We can also calculate the grand percentage, okay, total, 40 divided by 80. So we can calculate 3 percentages. That we will do in another class called cross-tabulation. We will calculate the column percentage, row percentage, and total percentage. Okay, but for this frequency distribution, we will not be doing that. We are just looking at the number based on the two characteristics. Huh? Okay. Now, part of your, we have so far looked at some distribution and graphical display of tables. Next, we will move to charts. There are several charts that we can visualize our data. One of the chart is called a bar chart. The second one is called a pie chart. The third one is called stem and leaf diagram. Okay. And finally, we have the third one is the stem and leaf diagram. So for categorical data, we can do bar chart and pie chart. For quantitative data, we can do stem and leaf diagrams. Okay, stem and leaf diagrams. Okay. The first one, which is called the bar chart. Okay, bar charts are graphical presentation of categorical data with rectangle or bar, and the bar is representing each of your category or class. Okay, each of the category of class. The length or the height of bar represent the frequency or percentage of observation. Okay, so what is meant by height means if you have a vertical bar, it is height. If you have a horizontal bar, you have the length. Okay, so those are some of the things you can look at. So the bar can be vertical or horizontal. So this is what we call as the vertical bar chart. So we have the year from 2010 to 2016, and we have a Standard & Poor 500 PE ratio. So 2010, the PE ratio is 20. 2011, 16.3. What it means is if the bars are taller or higher, the values are higher. Okay, PE ratio is higher. Okay, so this is the lowest, 14.87. This is the highest, 21.21. So instead of looking at this, we can quickly visualize them when we do a bar chart with vertical bar chart. Okay, this is another vertical bar chart of new car sales by the company, Daimler, BMW, Volkswagen. So we can see quickly here the highest number of new cars sold in US in the year 2015 is General Motors, okay, followed by Ford and Toyota. The smaller number is BMW and Daimler. Okay, so these are some of the ways you can present whatever data you have here in terms of the vertical bar. We can also present the bar chart in this horizontal manner. Here they have 2 years, 2014 sales and 2015 sales for each type of car, Daimler, BMW up to General Motors. So here we can see quickly the difference in the percentage or number of cars sold by General Motors in 2014 is this bar, 2015 is this bar. So in 2015, the sales went up by 5%. Okay, whereas if you do this kind of comparison, we can see quickly which car has more percentage increase from 2014 to 2015. So we can quickly get a picture from the bar chart, which is horizontal. We can also do bar chart comparison in vertical format. This is also easier to visualize. So we have male and female with these two colors, right? This is male, this is female. And then you can see the salaries, starting salaries of male and female. Most of the bar charts show you that the starting salaries of male is slightly higher than female. Okay, but like here you can see a bit different. In 2016, the difference has become very small. Although in 2015 is bigger. This is showing smaller. So we can actually compare male and female in terms of salary by using this vertical bar chart. Another graphical description of data we can do is with pie chart. Pie chart, we will draw a circle, and some of the slices will represent each of the class or category. Yeah? Okay. So let's say you have 5 groups. Each of the slice will represent the 5 groups. Okay. And the size of the slice will be proportional to the size of the group. So we will divide by the number. So first we will start with defining the categories like what we already did. And then for each categories, we will calculate the number. And then only we can construct the pie chart. Okay. So the number will be for each class, what is the number divided by the total number. That will be the pie chart. So here we have 1, 2, 3, 4, 5, 6 classes, right? Okay. Golf ball, club head material, shaft material, club head size, and so on. Okay. This total, when we take the total, after we take the total, we take the first category 81 divided by the total, we will get the bigger number, right? Okay, like here, golf ball, right? See here, 81 divided by the total, we get the bigger slice. Whereas here 3 divided by the total, we will get a very small slice. Okay, so the slice will be proportionate to the number, okay, and this number we will divide it by the total number. Okay, total number. So here we can see the different kinds of investment portfolio distribution. And here we can see that for this group, they have a very big return, 34% return, right? Okay, we can actually look at this. Okay, this is how pie charts are shown. And sometimes we also see people presenting the pie chart incorrectly. What is meant by incorrectly is here we have tax dollars spent per student in these 4 universities. How much tax dollars spent in Idaho? How much of per student tax dollars spent in Boise? So what we do is, let's say we draw a chart like this. Like this, right? What is wrong with this chart? Yeah. Yeah, anybody? Yeah, one is you cannot see the difference, lah. You are colorblind, Zan. Okay, no. This one is incorrect use. Remember, yeah, here we need to take this number divided by the total. We cannot present the 81 in the slice. We cannot, not proportion, correct. It's not proportion. So here is actual dollar spent, right? So what you need to do is you need to have the total amount spent and then which university get more or less. So this is not proportion, right? So you should not be using this pie chart. You can use the bar chart. Okay? Bar chart, you can see that in Idaho, they spend more tax dollars compared to Lewis and Clark. Okay, Lewis and Clark. Okay, so to do pie chart, it must be proportion. The total, you take each group divided by the total, then only we can do a pie chart. If not, you can do a bar chart. Okay. And another diagram that you can present is called the stem and leaf. Stem and leaf. So after you have all this data, the stem and leaf diagram, we will first need to sort the data from the lowest value to the highest value. And then the leaf will present the unit. Okay, so we have here these numbers, right? Okay. Let's say the lowest number is 42 here. What they say is lowest value is 44. So we will start with the number 4 and the leaf will be 4. Okay, 4, 4. So the last number will be 19 and the leaf will be 8. So that is how the stem and leaf works. We will sort them first and then here, just now we were saying 44, right? 4 is the stem, another leaf is 4. So we have only 144 in the whole data set. Okay. We have 153 in the data set. We have 157 in the data set. We have 259 in the data set. That's what is meant by the leaf. 59. We have 62, 262, 163, 166, and 267 and 269. So these are actually the leaf, the second number. Okay, the second number. The last category we have 190, 190, right? 192, 192, 198, 1. Okay, so if you look at your data here, can you see? 198, right? You have 1, okay. 192 you'll have. So that's how the stem and leaf works. Based on this data, these are the stem. The lowest number is 44, right? And the highest number is 198. So 4 until 19. So the second number will be the leaf. Second number will be the leaf. Okay. Another chart that is also used for presentation is called the line chart, the scatter diagram, and Pareto chart. Yeah, you can. Stem and leaf you can do with SPSS and Excel. Okay, so we will not be. We usually don't do this manually. Okay, maybe in your undergraduate you will do this. Okay. Okay, line chart and scatter diagram. Okay, line charts are two-dimensional chart where you have time on the horizontal axis and the variable you are interested in on the vertical axis. Okay, it is like a time series data. Okay, time and some characteristics of interest. Whereas for scatter diagram, this is a two-dimensional graph. You have two characteristics. You want to see whether the two characteristics move in the same direction, increasing or decreasing. That is the difference between line chart and scatter diagram. So here we have a line chart of a year. Okay, we see here 2003, 2004, 2005, 6, 7, 8 until 12. And then we have their, let's say, mobile home sold. Mobile home sold, 1,426, 1,600. So when we draw this, we can see that the trend is increasing. So from the line chart, we can see whether the trend is increasing or decreasing. Here we have only one characteristic we are interested in, which is the number of mobile homes sold against time. Okay, then we will call them a line chart. No? Okay, to construct a line chart, first we need to identify a time series variable. For example, day 1, day 2, day 3, day 4, or year 1, year 2, year 3, year 4. Okay, that's the first thing you need to do. And then we need a horizontal axis for the time, and the vertical axis will be a variable we are interested in, amount of sales, okay, amount of expenditure. Those kind of variable will be on the horizontal axis. And then we will plot, okay, we will plot, and you connect the line with straight lines, okay, you connect the line with straight lines. So here we have two trends, right? We have week 1, week 2, week 3, week 4. This is the time, okay, week, in terms of week. So you have 1 to 20. And then on the vertical axis, we have the profit and sales. Okay, so if you look at these two tables, here the trend, sales trend looks like going up, and the profit trend is like straight, very straight. So here, why it looks very straight is because of the same the scaling that you use. The scaling that you use. We can actually do them like a line chart like this. If you do them in line chart for those both the same sales dollar and profit, if you see this profit the line is straight, right? Okay, looks like very straight, no increase, no decrease. But for sales, it's increasing because the numbers are larger, okay? Because of the scaling. So if you have this kind of data, you want to see two different variables in the same chart, you should not have one scale. What we can do is we can have two scales. On the left is for sales, on the right is for profit. Okay, so if you do this together, you can see clearly that for sales, it is increasing, but for profit, it is decreasing. Okay, so we can actually do both this line chart and superimpose them with different increment here, the labeling here, right? Okay, so that also can be done, so that we can see a comparison. Usually when we do scatter diagram, we will have this term called dependent variable and independent variable. The dependent variable will be on your y-axis. Your independent variable will be on your x-axis. Okay, so what we are saying is the y-axis is actually dependent on your x-axis. Okay, independent variable will influence your dependent variable. So this is where we will need two quantitative variables. We will plot them in the chart, okay, like this. So here we have a positive linear relationship. Okay, positive linear relationship. Here we have a negative linear relationship. Okay, so they are still relationship. Here we have a curvy linear relationship, which is like this. This is also a curvy linear. Curvy linear. That means the lines are not linear. They actually curve a bit. These two charts, there is no relationship because there is no pattern of increasing or decreasing. There's no clear pattern of whether they are curving or not. So these are the kinds of relationship that can be revealed when you draw scatter diagrams. Okay, scatter diagrams. How do you construct scatter diagram? These are the four steps you can follow. First, we need to identify the independent and dependent. Now, this is your dependent. This is your independent. This is the first thing we need to do. And then we need to collect the values for both the variable independent and dependent. And the third step, we will put the values on the vertical and the horizontal axis and the plot. But for scatter diagram, we will not connect the plot or dots here. Can you see these dots? We don't connect them like the line chart. Here we just point them like this. We want to see whether the line is going up or the line is going down. And that is why we call them a scatter diagram. Okay. So this is an example of a scatter diagram. The volume per day, this is the number. And then we want to see the cost per day. So the volume, does the volume influence your cost per day? The more volume we have, the more cost we will need, right? So that's why the number is increasing. So you can see the trend of going up, right? Okay, the trend is going up. The more volume per day, the more cost per day you need to incur. Okay, which is counterintuitive, right? Okay. Okay, we can also have a chart like this, right? This is with the grid. Okay. Horizontal grid. Here is without the grid. We can also do that. So we can see some kind of curvy linear relationship, right? Okay. Not linear. Okay. So these are some of the things you can do with scatter diagram. Okay. When you draw this scatter diagram, you can see relationship between two variables. Here we are looking at processor speed and the price. Okay, processor speed and the price. Do they move in the same direction? That's what we will do with scatter diagram. And the final chart that many people use in the business is called the Pareto chart. Okay, the Pareto chart is trying to separate the vital few from the trivial many. What it means is we want to identify the most important characteristic. This is also done in quality analysis. Let's say we have defects. We have many kinds of defects. We want to know which defect is the most important to be tackled. So what we will do is, after we get all the defects, we will sort them from the highest to the lowest. Okay, from the highest to the lowest. Huh? So like this. Huh? So we have this company which is tracking the causes of machine downtime in terms of minutes. Huh? And these are the reason for the downtime. Huh? So broken belt, electric issue, operator error, maintenance, waiting on materials, and others, right? These are some of the reasons why there is downtime. Okay? And these are the minutes that the system is down. Huh? So what we will do is we will sort them from the highest value to the lowest value. Huh? So our downtime is from 0 to 450. And we can see here that the waiting on material is the most important reason why we have downtime. Okay, so these are the more not so important. So to improve your downtime, we need to focus on waiting for material. So the flow on material is the one we need to focus on. Okay, so this is the use of this chart called the Pareto chart. Okay, so those are some of the tabular description of the bar chart, pie chart, and so on. So this is the chart that is used for quality. Quality purposes, we want to identify the biggest concern for our quality by looking at the Pareto chart, which is 80-20 rule. So those are some of the issues discussed in chapter number 2. Okay. Some of these tables and charts you can use as part of your assignment and project. The assignment part, not the project part. The assignment part. Okay. Any questions on what we have discussed so far? Okay. So for your assignment, okay. So I will show you a bit on the assignment. Last week we already discussed this. This part here, you should be able to do. Okay, this part here we will discuss a bit later. So this first part here, preparing the data, screening the data, cleaning the data. Last week I've already discussed most of the things that you need to do. We already discussed about how to import the data into SPSS from Excel. Okay, how to define each variable. This is only for nominal variable or categorical variable like gender, marital status, those kind of variable. And I showed you how to do screening and cleaning the data. Okay. I also showed you how to run reliability for the variables in your model. So you will be given the model. Based on the model, you need to run reliability. How to report the reliability table later I will share with you. That's not a concern, but you need to do that. I also showed you how to do compute and recode that you need to do for those variables which are reverse coded. You need to do reverse coding before you run reliability. Okay, before you run reliability, you need to do reverse coding. After you run reliability, then only we will do a function called compute. Okay. Describing the sample, you can already do, like I already showed you, bar chart, bar or table. You can present them in a frequency distribution table. You can also do bar chart, pie chart if you want to, but those are not needed. Okay. This is all group. I already mentioned 100 times again, Chen. Okay. Your assignment and project is group work. I already gave you sample, right? Okay. You can see the template. Assignment template. You already have like this, right? Okay. So it is group work, not individual. The only individual assessment is your test, okay, which we will decide the date. Okay. Pareto chart is used for quality improvement. Quality improvement. Okay. Quality improvement. Okay. So these are things I've already discussed last week, but I missed one. I think missing value. Okay, but your final exam is face-to-face, Kang Dian. God bless you lah. You can do whatever you want lah. You need to know which one to use when. Okay. If you are relying on ChatGPT too much, then you don't know what they are doing. Sometimes they can also do mistakes. Okay. Midterm date you want to do when also can, Kala, yeah? But I will tell you when lah. Okay. We need to cover the other classes before we decide on the midterm. Maybe we will do after the break. Okay. As we go along, I will let you know. So last week we already I missed one more description that you need to do called missing value. So I will go through this part which I didn't discuss last week. So that the part where you do this part all will be covered. Before we move on, as we go along, we will also learn this in other classes. Normality and all, we will start learning them in the next few classes. So the one I missed is called the missing value. So this is actually already in your slide called data preparation. I just took them out a bit. So I will quickly go through this discussion about missing data. Okay, and you will have missing data in your data set. So when you collect your data, you will have this term called missing value. Why this missing value happens? These are some of the reasons. If you are doing survey, respondent did not answer, or they chose not to answer, or they miss. Instead of ticking them, they forgot to tick. So these are some of the reasons why missing value happens in survey research. If you are collecting data using sensors, suddenly you have a power cut. So during the power cut, the sensor will not be working. So you cannot collect data which is live, right? If you collect data using the internet, let's say your network is down or the network is lost, okay? You will lose some data, right? That is what we call as missing data. Missing data. Okay, why missing data is important is because these are the effect of missing data on your analysis. So when you're doing analysis, we will have two values that you are interested in, called your parameter and also the standard errors. So the missing data will influence this parameter to be biased. That means your parameter can be higher than what is supposed to be. The standard error can be higher or lower than what it is supposed to be. Okay? Those are the things that is called bias. If you have many missing value, and then the variability will go down because the number of sample size is smaller, variability will go down. If your sample size goes down, then your use of data is inefficient. Okay, so this will inflate type 1 and type 2 error. That is why missing value need to be addressed. For missing value, we have three types of missing value, which is called missing completely at random. We have missing at random and missing not at random. This missing not at random, it happens with your data, you cannot do any kind of missing value replacement. Okay, this one, missing not at random. What is meant by missing not at random is, let's say you have a long questionnaire, all the respondents do not answer the last part of your questionnaire. That is a pattern. That is a pattern. Missing completely at random means the missing values happen randomly. Okay, there's no pattern. For one respondent is missing in the question number 1, another respondent is missing in question number 10 or question number 15, right? So the questions, the missing values are not for certain questions or certain part of your questionnaire. Okay. Missing at random is when the missing values are related to some variables in your data. For example, the income of the person is low, so he doesn't state the education level and the income. These two are actually correlated. That is what is called missing at random. The missing values are missing because of certain characteristics of the respondent. They don't want to disclose. So that is the three types of missing value you have. Usually in the software, they will use two types of deletion. One is called list-wise deletion. The other one is called pair-wise deletion. What is the difference is like this. Let's say you have 1, 2, 3, 4, 5, 6, 7, 8 respondents. And out of the 8 respondents, respondent number 2 did not answer this variable. Respondent number 4 did not answer this variable. Respondent number 5 did not answer this variable. And respondent number 7 did not answer the gender. So as long as any of these are missing, 1, 2, 3, 4, these 4 cases, we will delete them. That is called list-wise. List-wise. That means any value missing from any of your question in your questionnaire, you will delete them. 1, 2, 3, 4. Whereas for pair-wise, you are saying, okay, let's say we keep all this respondent information. When we analyze gender, we have 7 complete data. 7 complete data. Let's say we want to analyze gender against sale. Okay. Here we have 7. Here we also have 7. But unfortunately, the data we have here, right? We don't have here. We have this data here. And here we have this. And we also, here we have the gender, but we don't have the sales. So when we analyze gender and sales, we will only analyze 6 respondents, the complete ones. This one and this one we will not include. Okay, we will not include. When we analyze gender and employee, we have 1 here missing, 2 missing, and here also missing, right? So 1, 2, and 3 we cannot analyze, right? So the number of responder we will use in the analysis is only 5 people. Okay, so that is what's called pairwise. This one we delete all the missing ones. This one we only, the number will go up and down. Okay, those are things done. But these are all not recommended in the literature. So we also have this traditional missing value replacement, which is available in most textbooks. Number one that many people do is no replacement. That means if you have missing value, you do not do any missing value replacement. This is possible if your missing value is 5% or below. Okay, 5% or below, then you can don't need to replace this one. Anything more than 5%, we can try other missing value replacement. One of them is called midpoint of the scale. A midpoint of the scale is like this. We have scale 1, 2, 3, 4, 5. The midpoint is 3. All missing value we will replace with the number 3. Okay, that is called midpoint of the scale. Number 3 strategy is we use a random number. We have 7 answers in the questionnaire, and we write 7 numbers, put into a box, and we pull out 1 number. We get number 7. So we will replace all the missing value with number 7. Okay. The number 4 and number 5 is called the mean value replacement. Mean value replacement is like this. We have 3 questions answered by 3 respondents. Respondent number 2 answered question number 1. He answered question number 2, but he did not answer question. He answered question 1. He answered question 3. He didn't answer question number 2. So we take the average of all other responses of the same person. So 4 plus 4 is 8. 8 divided by 2 is 4. So we will replace a 4 here. Okay. This is mean value of other responses of the same person. Another strategy is mean value of other respondent. So question number 1, respondent number 1 answered, respondent number 2 answered, respondent number 3 did not answer. So we take 2 plus 4, which is 6. 6 divided by 2 is 3. So we will replace 3. So this is column wise. This is row wise. These are some of the strategies suggested in textbooks. these are all no longer applicable. You should not be doing them anymore. So currently we have what we call as the hot deck imputation or the cold deck imputation. Hot deck imputation is in your data, you have a missing weight weight here, right? Okay. But we have other data that is about those people who have a height of 66. They have this number 260, right? So we can actually take the 260 and replace here. Okay, for those who are 66, for those who are 62, we take this number and replace here. That is called hot deck imputation. From the same data. Cold deck imputation means we have data collected previously. We use those numbers to replace. Okay, here it is from the same data that we already collected. A person who has a height of 66, he has a weight of 260. So for this missing person, we will replace with 260 here. Okay. For this person who is 62 in height, we will replace with 145, which is from here. Okay. So this is called hot deck imputation. But currently we have a software called SPSS where we can use this single imputation. So in the software called SPSS, you can run missing value analysis based on this link called analyze missing value analysis. And we pick the variable that has missing value. And we can run this method called expectation maximization. Once you run the expectation maximization, we can save the data into a new set of data. Okay, new set of data. The file name is called no missing. So what they will do is they will replace all the missing value with some numbers only for the variable you selected. One of the tests they will run is for this test called Little's MCAR test. This test says if the data is missing completely at random, then you can do replacement. If it's not missing completely at random, cannot do any replacement. So when we run the test, they will give you this Little's MCAR test. If the p value is less than 0.05, they are significant. That means you reject this. Okay. Then you cannot do missing value replacement. In this case, the p value is greater than 0.05. So we conclude that the data is missing completely at random. Okay. If it's less than 0.05, you will reject the null. If it's greater than 0.05, you accept the null. Okay, that's the rule for p-value testing. So since we conclude that it is not significant, we will accept the null. We can do missing value replacement. Okay, that is how the software will replace, and they will create a new data file called no missing. Okay, so in the data that I already shared today, I already updated the data. So this is the data I already updated. We have these three items called share 1, share 2, and share 3. So what you need to do is you will run analyze. Okay, what you do is you can run analyze, descriptive, and descriptive. You pick all the items you have, which is multiple item scale. You move it to the right. Okay, we don't need this. Okay. And then we want to see the missing value. Okay. Okay. Your sample size is 195. The one which has more missing value is share number 1, share number 2, and share number 3. Okay. This has missing value. Okay. So these three items, the percentage is more than 5%. So what we need to do is we need to run the missing value replacement. So when we run the missing value replacement, you go to analyze, missing value analysis. Okay. Pick the three items that we want to analyze. Move it to this side here. Okay. And we want to pick this EM, which is expectation maximization. And then when you click the EM, you get this chart. Okay. We want to save the completed data and the file name. You can give any file name. I use this name, no missing. Okay. They will only replace the number for these three items. Okay. These three items. So when you click continue, and then you click OK, they will give you this Little's MCAR test. Can you see here? Little's MCAR test. Okay. Here, correlation and okay, here, this one, sorry, EM mean. Okay, if you look at the EM means, the Little's MCAR test, it is not significant. Then we can do replacement. Okay, then you can do replacement. So if you look at your data here, Windows, we see here we already have a new file called no missing. Okay, no missing. Okay, so if you open the no missing, if you see the three items only is replaced. So if you see this item, the number is actually not a round number. It can be any number that they replace. So what we need to do is we need to highlight all these control A. Okay, control A. We need to select all this new data that is no missing. There is no more missing here. Copy this data, and in your data file here, you need to paste. So once you paste, now you have a complete data set. Okay, this you need to check also. The data that you are given for your assignment, you need to check the total number that you have. Okay, here we have 197 cases, right? Okay, so you need to know if it's more than 5%, then you need to do replacement. Less than 5%, you don't have to do replacement. So that's how you decide on this missing value replacement. Okay, so that covers all the things that you need to do under the actions. Okay. So if you do missing value replacement, you have to tell, you have to write, when you're writing your report later, you need to tell, how did you do your missing value replacement, how many cases are missing, and so on. That part you need to describe here. Okay. Yeah. Any questions on the missing value replacement? No? No? Okay. So your assignment and project is one file. But when you submit, you will submit two files. One is label. I already give you the template, right? You can look at the template. We have a template for assignment. We also have a template for project, right? Okay. Please look at the different, the two files. So when you submit two files. One for the assignment. The other one is for the project. I think this one, right? Okay. This is the project. It is the assignment. Okay. So those are the two files you need to prepare. So now, while we go through the other classes, you can actually prepare your data while waiting for what analysis to use. As we go along, we will be discussing all this. Some of the tests will be t-tests. Some of them will be one-way ANOVA. And later we will do an analysis called multiple regression analysis. So those things you will need to do and report them. Okay. How to report the tables later I will also share in the classes. Yeah. Any other questions for today? Yeah. What is the question? Yeah, you're supposed to do that, right? Okay. The result objective, result question, they are already given in the case, right? assignment 20%, project 20%. Already written clearly, right? There are two different things. 20% is for assignment, 20% is for project. We don't have minimum pages for assignment and project. Okay. We don't have minimum references. Okay. The deadline can be from tomorrow until the 15th week. Okay. I will create a link for you to submit. One link for assignment, one link for the project. Okay. Anytime. You can submit anytime until week number 15. Because we have to do the grading before week number 16. Okay, the objective and all is dependent on the kind of test you do. Okay, this is relationship. This one is not relationship, right? These are tests of differences. Okay, you want to do a presentation? I can also arrange. Okay, that is not part of the deal. You need to submit a report on it. No presentation. Yeah, I guess so. Yeah. Only the leader. That's why I asked for the leader. Remember, in the first class, only the leader will submit. One assignment, one project. Missing value is already there. You hang. I think missing value. I already gave you this file last week, right? Can you see this chapter data preparation? This one, right? Data preparation and analysis week 2, right? It's actually in the slides. It's already in the slides. You can go and see. Yeah, here. Can you see? They're already here. I just took them out for this of presentation. Okay. Yes, any other questions about the assignment? So you can prepare the data first. As we go along, I will show you how to do some of these tests. Okay, when we learn t-test, when we learn one way and over, then only you can. Towards the end of the class, we will learn how to do multiple regression. Okay. You want to do also can. I can arrange for that a presentation. I already repeated 10 times. Page over. When you want to take the midterm, I already mentioned just now, right? Okay. I will let you know the date. Most probably after the break. After the break. We will do the midterm test after the break.
Hello, hello, Professor.
Yeah, Liu, you have a question?
Yes, I have a question. All of the assignment and the project are the group work.
I will throw a bottle at you, Liu. I already repeated, I think 5 times. Okay. Did you see the sample I already shared? Okay. The template. Can you see here? Is this individual or group? We don't have minimum maximum for the page. You can write 100 page also if you want to. We mean. If you can write now. Okay. You need to answer the question. If you see here, we already have the question, right? Okay. For each section, you have questions. Just answer the question. This question. You will have table. You have this description of the test, right? Okay. As you go along, you learn all the 3 tests one way and over. Then you see how you can present them. That is for both test, the assignment and the project, right? Different kinds of tests for the assignment and the project. Okay. But the assignment and the project is one. Okay, from the same data.
Okay, thank you.
Okay. Okay. If no further question, we will stop here tonight. Next week, we will be face to face. Okay. We have DK, SK3, and SK4. Okay. So I will see you next week in the class. Okay. Okay, for those who are face to face, you are supposed to mark your attendance. So please do mark your attendance. Don't wait until you forget.